Hello guys, this is Sahilkamboj and welcome to my YouTube channel Data Science Story. In the previous video, we have learned what is bias variance trade-off and what is the best situation for us in the bias variance trade-off. And in today's video, our agendas are like we try to understand what is regression analysis and what is a simple linear regression in particular, and try to create a linear regression using a data set that is come along with this ISLR book. And then we try to analyze the summary report of the stats model, and then we will try to understand what's the significance of the p-value and how we can use the p-value for our understanding about the data set. And then we try to assess the accuracy of the linear model that we have created using the stats model. And then we will learn what is RSquared and what's the significance of the RSquared, and what we can understand from the values of R². And then in the same line, we will try to understand what is RSS, that is residual sum of squares. And then we will understand what is residual standard error and how we can find it, and what can we inference from the value of the RSE. So guys, let's start our today's video. So what is regression? First, let's try to understand this concept. A regression is nothing but it's a statistical modeling method in which we try to establish a relationship between the dependent variable and the independent variable. As you know, dependent variables are our response, and the independent variables are our predictors that we have for our data set. So, and in particular, the linear regression, simple linear regression, is a useful tool for predicting a quantitative response or output value. And one thing I also want to understand, that if you want to understand more complex methods of the machine learning, your first step will be always to understand these basic concepts of linear regression. If you learn this concept, then you will probably able to understand the other complex methods of the machine learning very simply. Okay, so our basic approach to understand this linear regression will be that we are going to take a data set that has come along with this ISLR book and try to understand the concept of simple linear regression using that data set. So as a data scientist, whenever you get a client data, and you will be presented with a business problem that you can get from your client. So here let's create a scenario. So as a data scientist, you are asked to suggest on the basis of the data set that has been presented to you a marketing plan for the next year that will be result in higher product sales. Okay, and the informations that is provided in the data sets are the advertising budget of 3 different media like TV, radio, and newspaper. And based upon the business problem, if you are the quality of a good data scientist can be analyzed from how qualitatively he framed the questions from that given business problem. Let's like from this given business problem, we have framed 7 different questions that we will try to answer in the last once we understand what is linear regression, simple linear regression, and what is multiple linear regression. So let's have a look at these 7 different questions that we are trying to answer. The first question is there any relationship between the advertising budget and the sales? And the second one is how strong is the relationship between the advertising budget and sale. So first we try to analyze, is there any kind of relationship between budget and sale, and if yes, then how strong is that relationship. Then we will try to understand which media contributes to the sales. So we have given the budget advertising budget of three different media: TV, radio, and newspaper. And we will try to understand which media contributes to the sale, okay, the most. And then we will try to understand how accurately can we estimate the effect of each medium on sales. And then we will try to understand how accurately can we predict future sales based upon the linear model or the regression model that we have created. And then we will understand, is the relationship between the dependent variables and the independent variable is linear. And the last question that is we have created from this business problem is there synergy among the advertising media. Once we created the linear regression model, we will again look into these 7 questions, and if you don't understand any of these, you will get the most idea once we answer these questions. Okay, so let's create our simple linear regression using Statsmodel. So we first with the very first basic step is we try to we will import the basic Python libraries that we are gonna use. So we will import the NumPy, we will import the pandas, and then matplotlib for basic exploratory data analysis or visualization, and seaborn to get the more graphics. And then in the last we import the stats model, and this is the package that is built on the top of NumPy and SciPy, which integrates with pandas. And the very basic idea that I have used this stats model, that it provides a very good summary of the linear regression fit that we have created. And you will understand what I'm telling you right now, okay, later. So let's first import these libraries. It's done, and we are going to import the data set using the pd.read.csv, and that is the advertising data. So let's have a look at the data. And this is our data. In the data we have presented with our output, that is our response, that is sales. We are going to predict this, and with the 3 different advertising media data sets like TV, radio, and newspaper. And we don't have any use of this unnamed data, so we will drop that. Okay, so let's have the look of the columns. So here, and then we are going to drop the unnamed column, because this is a kind of ID for these sales. So we don't have any prediction value for this column. So let's done. So we are going to use the data.describe methods, and it will present a very good summary of the data sets, and it will tell us how much data is presented and what are their mean, median, and different percentiles it give us. So each column has a count of 200, and so basically we have 200 rows that are observations, or you can say that observation that we have given, and their mean values are given here. So let's create our first regression from here. So the very basic understanding that if you are ever try to create a regression, it should be meaningful. And if it's not meaningful, and if you're not trying to understand from the regression, then you shouldn't create any regression. Okay, so first we are going to split the data set into 3 different x and the y that we are going to predict later. So here our three X, like first X is our TV, that TV advertising budget, and the X2 is our radio advertising budget, and the X3 is our newspaper advertising budget. So let's create it. Done. So let's we're gonna explore the data set that we have given, and we are gonna take the each different X with respect to our Y sales. Okay, so let's have a look at the data. So see, and then this with respect to newspaper. So if you look clearly look into the all the three different graphs, you will get an idea that the TV budget and the TV budget with respect to sales is kind of more linear relationship with respect to the sales, and the radio budget also have kind of more linear relationship with respect to sales, but the newspaper budget is kind of random. Okay, and we not able to find any particular pattern that is available in the data set with respect to the sales. So from the basic EDA, or you can say exploratory data analysis, you get an idea that TV budget is more have kind of relationship with respect to our response, that is sales, then a then radio budget, and the least relationship that is present between the output and the input, that is we found in the newspaper budget. So let's guys, we are gonna create our first linear regression model using the stats model. You are finding a very simple equation on your screen, that is y hat is equal to the b0 plus b1 into my x1. From your class 9th 10th, you are very much familiar with this kind of equation in your coordinate geometry, and this is very basic, guys. If you understand this equation, then you will understand what's the concept of linear regression, what's the concept of regression itself. Okay, so let's check this situation, what it is and what it tries to tell us. So let's try to create a relationship between the y and our predictor, that is x, and it's tell us that x is somehow related with the y, that is our sale, by some amounts like b0 and b1. Okay, it's this basic thing that it is telling to us. And so let's create our first regression model, and in we are gonna use the stats model that we have imported in the library section. So SM our stat model. So in the first line of code, what we are doing, that we are just adding this constant, that is x0, that is equal to 1 in our linear regression line. So it is created with this single line of code, that is x is equal to may sm dot add constant of x1. Okay, and then we write a code like result is equal to sm dot ols, and we're going to provide it with our response y and then x and dot fit, and then we just write results dot summary, and it's gonna represent us with 3 different sections of summary. So let's check. So here, guys, it presents us with 3 sections of reports. This is 1, and then this is 2, and this is 3. We are gonna understand this summary from very basic, that if you understand this report, you are gonna be create a very good regression fit later on. Okay, so guys, first we are gonna understand what is this t statics and what is this p value. Okay, The simple understanding that the t statics and the p values are the values that are something related with the hypothesis testing. And what is hypothesis testing? Guys, I'm not gonna try to give you the all the fundamentals concepts of the hypothesis testing, but I'm gonna give you the summary of this, that in the hypothesis testing we have created two hypotheses. One is called the null hypothesis, and the opposite to the null hypothesis is called the alternative hypothesis. Okay, so the null hypothesis is the status quo. Okay, and in null hypothesis, and in particular to this problem, what's the null hypothesis, guys? These are the coefficients that we have found, that is b0 and that is b1. Okay, and the null hypothesis is that is the coefficients like b0 and b1 are 0. Okay, and the alternative to null hypothesis is that the coefficients, that is b0 and b1, these are that the b0, and alternative hypothesis is that the coefficients like p0 and the b1 and the b1 are not 0. And what it's trying to understand from the p value is that if the coefficients are 0, then there is no relationship is present between the x and the y. And if the coefficients, that is our alternate hypothesis, are not 0, then there is some kind of relationship is present. So this is the basic fundamental understanding that we are trying to get from here. So what we can imply from the values of the p is that if the values of the p are less than 0.05, or in some particular cases is 0.01, then that variable has significance for our linear model. Okay, so you clearly see here that the values for p are like 0.000 and 0.000. So from this we just clearly implies that our variables has some kind of relationship with respect to our response, that is our output. We have successfully able to reject the null hypothesis that the coefficients are not equal to 0, but the coefficient has some kind of value that is not equal to 0, and the variables, and it implies that variables has some kind of relationship with respect to our response. So guys, once we reject the null hypothesis and accept the alternate hypothesis that the variable has, that is our x1 has some kind of relationship with respect to the sales, and the very natural basic step next is that we try to quantify the extent to which this model is has fitted our data sets, or in other term we are just trying to assess the accuracy of our model. So guys, let's assess the accuracy of our model. So to assess the accuracy of the linear regression fit that we have created, and it can be assessed from the two basic concepts, that one is R-squared statistics and the next is residual standard error. So first we will see what is R-squared, and then we will simply able to tell that by checking the value of R-squared we can tell that how the regression fit is good for our data set. Okay, so to understand the R-squared we will see this figure, and first we will, if we understand this figure, then we will very much able to understand the concept of R-squared. Okay, so let's do it. Okay guys, so this this is our x, and this is our independent variable, that is in this particular case is our TV advertising budget, and this is our y, that is our sales with respect to our TV budget. Okay, so this is the red line that you are seeing on your screen is the regression fit that we have created using the regression stats model. Okay, so from here, let's take a one random point, one random data set point, that is our yi, that is the actual data set point. And the point that you are seeing on this regression fit is our predicted y, that is, you can say that our y hat that we have seen here at this point. Okay, and this is our sales mean, that is y mean is our sales mean. So the distance between our actual sales and our predicted sale is called the residual distance, or you can is called the residual distance. And the distance between our mean sales and the predicted sales value for a particular x is called the sum of squares, and this sum of square is also called the explained sum of square, and this sum of square is also called the unexplained sum of square. Okay, so if we basically add these two distances, it comes for us is something we call the total sum of square. Okay, so you basically understand these three concepts. Okay, now if we the formula for r squared is like 1 minus residual sum of square upon the total sum of square. And what this formula give us, guys, it give us how much variability that our regression fit line tells us for this given data set. Okay, if the value is closest to 1, it explains very high variability of the data set, and if this value is close to 0, it explains none of the variability of your data set. So basically you're trying to create a model that has very good explanation of the variability for a given data set. So so people ask, what's the good value of r squared? Okay, so for this question there is no particular answer. For some fields of education, 0.0 is very much good value, and for some fields like physics, mathematics, 0.9 value of r squared is considered to be good for regression fit. Okay, so let's see the value of r squared for our regression fit. So it's like a 0.612. So our model has successfully able to tell the 61% of the variability of the data set. So guys, it's we just and yet we just take the one independent variable, that is TV advertising budget. If we take another predictor like along with this TV data set, that is radio, we may able to increase the value of r squared, or we may able to explain more variability of the data sets. And this thing we will see later when we will understand what is multiple linear regression. Okay, so I hope you guys understand what is r squared. And one more concept, guys, that is used to assess the accuracy of regression fit is called the residual standard error. And what is residual standard error, guys? And if we and this thing also we try to understand from a very simple graph like here. So this is our regression fit that we have created for this our data set, and these are the actual points of the data sets, and these red lines that presented here are the error terms, guys, are the difference between our predicted value and our actual value. And if we do the sum of square of these all error terms, we are presented with something called the RSS, or called the residual sum of square. And to find the residual standard error, what we do is we just do the square root of this and divided it by 1 divided by n minus 2. So now let's find the RSE, the residual standard error. So to find the residual standard error, first we have to find the RSS. And what is RSS? It is basically the difference between the actual value, that is the we have in our data set, and the predicted value that we predict with using our regression fit line. Okay, so to find this, we just write this line of code, that is y hat, and we use the regression parameters to find the y hats. So let's have a look how our y hat is looking. So these are basically the predicted values for this particular data set, okay, data points. And after we have created y hat, and we will now find the RSS. What is RSS? It is basically the difference between the predicted value and the actual value, and then do the square of those terms, and finally do the sum of those terms. So let's find it. So we will see that our RSS has been successfully calculated, and after ultimately now we will easily find our RSE. So we will use simply this formula to find our RSE, and we just do the square root of the RSS and divide it by the n minus 2. Here the n is 200, since we have 200 different market data sets for our given problem. And then we do the round function, use the round function to just find the value up to 2 decimals. So for our given problem, what it's telling us that the actual sale in each market deviate from the true regression line by approximately 3260 units. Okay, so it's we can use this value to find the percentage error for our problem. To find the percentage error, what we can do, that we just find the mean of the sales value that we have. We just write this code and find the mean of this value. We will successfully able to find the mean of this value. So approximately the mean is around 14,000, and if we divide the RSE with this value, we will find that 23% error for our given problem. So is it a good or bad model? It's basically depend upon the problem context. Okay, so in the regression line, what the algorithm tries to find is that it basically try to minimize this sum of square of residual sum of squares, and it uses its math, and it's give us that one particular line in which the residual sum of square is minimum. Okay, so just let's create a data frame that shows our RSquared value and RSE, and let's plot the regression line that we have just created using the Statsmodel for our given data set. So you can basically see the green line, and we have created using the Statsmodel, and you find that it's very much is between these actual sales data points. Okay, so, and similarly we can also create the simple regression for our different data sets, like for our radio data set, and then for our newspaper data set. And we can also plot these two different regression fit lines for different dataset budgets for the different X that we have. So you see that the for the newspaper, it's there we earlier see that there is no particular pattern between the predictors and between the response. I'm going to give you one problem that you should do by your own. Just try to find the RSC for the newspaper and try to find the RSC for the radio regression fit line, and try to compare with this that we have just created in our this video. And please comment in comment box what you have analyzed from these two different from these three different RSC values. The one is for that we have just found using the TV as a predictor, and then you have to find for the newspaper and for the radio. Okay, so guys, in the conclusion, let's have a look what we have understand yet. So we are given with a data set of 200 different market, and where the values of the three different medias are given. Okay, and then we just analyze that data set with respect to the sales, and we found that the TV budget has some kind of more strong linear relationship with the sales, and with respect to the others two budgets like radio and newspaper. And then we just create our simple linear regression fit regression line fit using the stats model. And then we are presented with this report or summary, and we analyzed how to read this report, and what we can imply from the reports. And we understand what is RSquared, and then we understand what is the significance of the p-value, and what are the coefficients of the regression fit line. And then we just simply created that regression line. And then we understand what's the null hypothesis and what's the alternate hypothesis in this particular case. And once we able to successfully reject the null hypothesis, we then try to assess the accuracy of the model that we have created. And in assessing the accuracy, we understand that two basic concepts. One is RSquared and the other is RSE, or you can say residual standard error. And we understand the more value in case of RSquared, more value close to 1, it's good for our model. And in case of residual standard error, the very more minimum value is our favorable for our particular model. And then we understand what is RSquared, and just RSquared is just a concept that tells how much variability your particular models explain for your given data set. And we see the formula of RSquared, and then we just understand what is a residual sum of squares. It's just basically the difference between your predicted value and your actual value. And then we understand what is residual standard error. It is basically the average amount of the response that will deviate from the true regression line. Okay, and if you want to understand more on these, I have given you the link in the description box that you can find and check it out. Okay, and then we just create the y hat, that is our predicted value based upon the regression fit that we have created. And from after creating y hat, we just do the difference between these two values, predicted and the actual value, and do the square of that value, and we come across with this RSS. And if we, once we created the RSS, once we find the value of the RSS, we simply apply this formula to find the residual standard error, and it gives us some value. And from this value, guys, this value can also be used to compare the two different models. If we later on what we find, later on what we will understand, uh, once when we create the multiple regression model, when we use the 2 or 3 different predictors, like in the regression fit line, we successfully able to minimize this value. So in the regression line, we simply try to minimize these values. Okay, this is one thing that we have understand, and then we just plot our regression fit line in a data set using the matplotlib, guys. So guys, that's all for our this particular video. And after this, if you have any kind of problem that you are facing with respect to any concept that we have understand yet, just comment in the comment box, guys. I will try to explain that problem. Okay, and in the next video we will create a multiple regression, and we will try to understand more concepts like what is adjusted R square and what is F statistics. How can we use these value to find or to compare two different models, and we will also do more understanding on the p-values later on, guys. Okay, so this is all, guys, for this video. Thank you very much. Let's meet in next video. So if you like my way of teaching, please subscribe my channel Data Science Story, and like this video and share with your friends or someone you feel that should see this video. So thank you very much, guys. Bye bye. Tata.